This section, we're going to be talking about units. Now, it might seem unusual to talk about units in a physics course. Why is that so important? Isn't physics about the numbers and the calculations, the equations? And this is a common misconception, but units are tremendously important. And they're important for two reasons. One, they make answers correct or incorrect. For instance, if you ask me, what's the population of the world? I might tell you 7 billion. Now this seems reasonable at first glance. 7 billion, that's the right answer. But I didn't specify what population. 7 billion people? That's correct. But what if I said 7 billion ants? Well, clearly, there are a lot more ants than there are people. So that'd be wrong. On the other hand, what if I said something like there are 7 billion skyscrapers? That doesn't make any sense. And there's clearly less than 7 billion skyscrapers. So in this case, it's clear. An answer is only right if you provide the right unit if needed. Now, what do I mean by if needed? There are a few very rare examples where the right answer is no unit. The first one is if it's dimensionless. A lot of times this happens if it's a ratio. For instance, what's the ratio of people in the US to people in China? Well, that answer is about 3 to 14. Now, why don't I have to assign a ratio? Shouldn't this be 3 to 14 people? Well, that's not quite right. If we say there's 300 million people in the US, and there's 1.4 billion people in China, the units of people cancels out and gives me 3 to 14. So in this scenario, the correct unit is no units. The other case is a lot of times you're dealing in frequency. Your frequency is measured in hertz, which is the same as second inverse, 1 over seconds. And what we're going to see is when you do hertz, that's really cycles per second. But we don't have a unit for cycles. We just say a number. So 10 hertz is 10 cycles in 1 second, or just 10 over seconds. So these are the two scenarios you're likely to see unitless, either when you're measuring cycles or you're doing a ratio. Other than that, you should always give a unit. And what are your fundamental units? Let's go through them. Your most basic units, and this is SI units, System International, are meters. Meters is a unit of distance. It used to be defined as a fraction of the distance from the equator to the North Pole. Now it's measured in terms of the speed of light. And this is a unit you've probably seen before. It's a little longer than a yard. 1 kilogram. A kilogram is 1,000 grams. And it's equivalent to 1,000 cubic centimeters of pure water. That's 1 centimeter cubed of water. Then there's the second. 1 second, that's defined as a certain number of oscillations of a certain number of a certain atom. You're not expected to know this, but it's just kind of interesting to see how that's defined. Then there's the ampere, the amp for short. The amp is the unit of electrical current flowing, and it's measured in a certain number of electrons over 1 second. It's charge per time. And once you get into the electricity and magnetism unit, you'll go into that unit in a little more depth. But for now, just knowing it's measured in charge per second, that's all that really matters. Then there's the Kelvin per temperature. You're probably familiar with the Celsius system, where 0 degrees Celsius is freezing. You get ice cubes there. And that 100 degrees Celsius is boiling. Kelvin is just 273.1 degrees, sorry, 0.13 degrees, plus the Celsius is Kelvin. And this is because 0 degrees Kelvin, rather than being the freezing point of water, is absolute zero. Now that said, this is a little inconvenient. This means even very normal temperatures, like room temperature, start off around 300 degrees Kelvin. So a lot of times we'll use Celsius. 1 degree Celsius, the change in 1 degree Celsius equals a change in 1 degree Kelvin. So it's easy to convert back and forth. And as a result, we'll a lot of times deal with Celsius even though technically Kelvin are the actual units. And then moving on to the final two, moles is a unit for amount of substance, and 1 mole is 6.022 times 10 to the 23rd units. So a lot of times this is used to measure electrons or molecules or atoms. And 6.022 is a very famous Avogadro's number. And the final one is the candela, which is luminous intensity, which you don't know, have to know at this part of the course, and it'll get covered if you need to know it. So these 7 units cover every system of measurement you'll need to know for the purpose of this course, and every other unit in this course is just a composite of these units. So next lecture, we're going to talk a little bit how you combine and mix and match units to get new units that cover more specific cases.